Hey, welcome to another experimental live read of Ragnarok, The Age of Fire and Gravel. Oh boy, cats coming off my lap already. So today we'll be reading, this will be a bit of a longer one. It's chapters 3 and 4 from part 2, The Comet. Could a comet strike the Earth and the consequences to the Earth? Part 1, The Drift, the first 8 chapters of that we've already gone through this week, so you can go back to the live tabs if you wanna see the pictures in the book and the live narrations there. So I'm Graham, one of the narrators of Adult Brain, adultbrain.ca. Please like and subscribe and all that good stuff. So this is like raw and rough how the sausage is made. I'm going to edit it as I go. Hopefully I don't make too many mistakes and snort and cough and all that. So so yeah, hope you like it. So we'll jump right into it. Oh, I got to share the screen too. I keep forgetting to do that. Let's see here. This will be, my PDF and the recording software that we use as I go along. Chapter 3. Could a comet strike the Earth? Reader, the evidence I'm about to present will satisfy you, not only that a comet might have struck the Earth in the remote past, but that the marvel is that the Earth escapes collision for a single century, I had almost said for a single year. How many comets do you suppose there are within the limits of the solar system? And remember that the solar system occupies but an insignificant portion of universal space. Just as a reminder, this is written by Ignatius Donnelly in 1883. Lots of scientific references, and it's interesting to see where the science was at back then, almost 150 years ago. Half a dozen? 50? 100? You will answer? Let us put the astronomers on the witness stand. Kepler affirmed that comets are scattered through the heavens with as much profusion as fissions in the ocean. Fissions? Fissions in the ocean. Let's do that one again. Comets are scattered through the heavens with as much profusion as fishes in the ocean. Think of that. 3 or 4 telescopic comets. 3 or 4 telescopic. 3 or 4. Check. 3 or 4 telescopic comets are now entered upon astronomical records every year. Lalande had a list of 700 comets that had been observed in his time. Arago estimated that the comets belonging to the solar system within the orbit of Neptune numbered 17,500,000. Lambert regards 500 millions as a very modest Lambert regards 500 millions as a very moderate estimate. And this does not include the monstrous fiery wanderers who may come to visit us, bringing their relations along from outside the solar system, a sort of celestial immigrants whom no anti-Chinese legislation can keep away. And here's a picture of the orbits of the periodic comets. Looks like they've got Ficus Comet. There's Halley's Comet right there. The orbit of Mars, orbit of the Earth. Encke's Comet right there. The orbit of Jupiter. Faye's Comet. Gambar's Comet. Borson's Comet. Check, says Guimond. Leaving mere reappearances out of the question, new comets are constantly found to arrive from the depths of space, describing around the sun orbits which testify to the attractive power of that radiant body, and for the most part, going away for centuries to return again from after. And for the most part, going away for centuries to return again from afar after their immense revolutions. But do these comets come anywhere near the orbits of the Earth? Look at the map on the preceding page from Amédée Guillemand's great work. The Heavens, page 244, and you can answer the question for yourself. Here you see the orbit of the Earth overwhelmed in a complication of comet orbits. The Earth here is like a lost child in the midst of a forest full of wild beasts. And this diagram represents the orbits of only 6 comets out of those 17 millions or 500 millions. It is a celestial game of 10 pins with the solar system for a bowling alley and the Earth waiting for a 10 strike. In 1832, the Earth and Biela's comet, as I will show more particularly hereafter, were both making for the same spot, moving with celestial rapidity. But the comet reached the point of junction 1 month before the Earth did. And as the comet was not polite enough to wait for us to come up, this generation missed a revelation. In the year 1779, Lexell's comet approached so near to the Earth that it would have increased the length of the sidereal year by 3 hours if its mass had been equal to the Earth's. And this same comet did strike our fellow planet, Jupiter. In the years 1767 and 1779, Lexell's comet passed through the midst of Jupiter's satellites and became entangled temporarily among them. But not one of the satellites altered its movements to the extent of a hair's breadth, or a tenth of an instant. But it must be remembered that we had no glasses then, as we have now, that could tell us what were the effects of the visitation upon the surface of Jupiter or its moons. The comet might have covered Jupiter 100 feet. Yes, 100 miles, thick with gravel and clay, and formed clouds of its seas 5 miles in thickness without our knowing anything about it. Even our best telescopes can only perceive on the moon's surface, which is, comparatively speaking, but a few miles distant from us, objects of a very great size, while Jupiter is 1,600 times farther away from us than the moon. But it is known that Lexell's comet was very much demoralized by Jupiter. It first came within the influence of that planet in 1767. It lost its original orbit and went bobbing around Jupiter until 1779, when it became entangled with Jupiter's moons. And then it lost its orbit again and was whisked off into infinite space, never more, perhaps, to be seen by human eyes. It is not reasonable to... Check. It is not reasonable to suppose that an event which thus demoralized the comet may have caused it to cast down a considerable part of its material on the face of Jupiter. Encke's comet revolves around the sun in the short period of 1,205 days, and, strange to say, the period of its revolution is constantly diminishing, so that if this progressive diminution always follows the same rate, the time when the comet, continually describing a spiral, will be plunged into the incandescent mass of the sun can be calculated. The comet of 1874, first seen by Koja, I'm just going to go back to my pronunciation. Koja. Check. The comet of 1874, first seen by Koja at Marseille, and called by his name, came between the Earth and the Sun, and approached within 60,000 miles of the flaming surface of the Sun. It traveled through this fiery blaze. Check. It traveled through this fierce blaze at the rate of 366 miles per second. 366 miles per second. When a railroad train moves at the rate of a mile per minute, we regard it as extraordinary speed. But 366 miles per second. The mind fails to grasp it. When this comet was seen by Sir John Herschel, after it had made its grand sweep around the sun, it was not more than 6 times the breadth of the sun's face away from the sun, and it had come careering. Check. and it had come careering through infinite space with awful velocity to this close approximation to our great luminary. And remember that these comets are no animalculae, animalculae. And remember that these comets are no animalculae. They are monsters that would reach from the sun to the earth. And when we say that they come so close to the sun, as in the above instances, it means peril to the earth by direct contact, to say nothing of the results to our planet by the increased combustion of the sun and the increased heat on earth should one of them fall upon the sun. We have seen in the last chapter that the great comet of 1843 possessed a tail 150 million miles long. That is, it would reach from the sun to the earth and have over 50 million miles of tail to spare. And it swept this gigantic appendage around in 2 hours, describing the arc of a circle 600 million miles long. The mind fails to grasp these figures. Solar space is hardly large enough for such gyrations, and it must be remembered that this enormous creature actually grazed the surface. Was that a creature? Was that a creature? I'm calling it a creature. And it must be remembered that this enormous creature actually grazed the surface of the sun, and it is supposed that this monster of 1843, which was first seen in 1668, returned and was seen in the southern hemisphere in 1880. That is to say, it came back in 37 years instead of 175 years. Whereupon Mr. Proctor remarked, "If already the comet experiences such resistance in passing through the corona when at its nearest to the sun that its period undergoes a marked diminution, the effect must of necessity be increased at each return, and after only a few, possibly 1 or 2 circuits, the comet will be absorbed by the sun." On October 10, 1880, Lewis Swift of Rochester, New York, discovered a comet which has proved to be of peculiar interest. From its first discovery, it has presented no brilliancy of appearance, for during its period of visibility, a telescope of considerable power was necessary to observe it. Since this comet, when in close proximity to the Earth, was very faint indeed, its dimensions must be quite moderate. The illustration on page 88 gives the orbit of the Earth and the orbit of this comet, and shows how closely they approached each other. When at its nearest, the comet was only distant from the Earth 0.13 of the distance of the Earth from the Sun. It comes back in 11 years, or in 1891. On the 22nd of June, 1881, a comet of great brilliancy flashed suddenly into view. It was unexpected and advanced with tremendous rapidity. The illustration on page 89 will show how its flight intersected the orbit of the Earth. At its nearest point, June 19th, it was distant from the Earth only point. Check. At its nearest point, June 19th, it was distant from the Earth only 0.28 of the distance of the Sun from the Earth. Now, it is to be remembered that great attention has been paid during the past few years to searching for comets, and some of the results are here given. As many as 5 were discovered during the year 1881. But not a few of the greatest of these strange orbs required thousands of years to complete their orbits. Here's a picture of the orbit of the comet, the orbit of Jupiter, the orbit of the Earth, and the lines of nodes and the sun right there. Check. The period of the comet of July 1844 has been estimated at not less than 100,000 years. Some of those that have flashed into sight recently have been comparatively small, and their contact with the Earth might produce but trifling results. Others, again, are constructed on an extraordinary scale. Here's another picture. They don't have a label for it, but it's got the Earth's orbit, the comet's orbit here, and the months and perihelion on June 16th, for example. Check. But even the largest of these may be but children compared with the monsters that wander through space on orbits that penetrate the remotest regions of the solar system, and even beyond it. When we consider the millions of comets around us, and when we remember how near some of these have come to us during the last few years, who will undertake to say that during the last 30,000, 50,000, or 100,000 years, one of these erratic luminaries with blazing front and train of debris may not have come in collision with the Earth? Chapter 4. The consequences of the Earth. Try that again. Chapter 4. The consequences to the Earth. In this chapter, I shall try to show what effect the contact of a comet must have had upon the Earth. Check, check. In this chapter, I shall try to show what effect the contact of a comet must have had upon the Earth and its inhabitants. I shall ask the reader to follow the argument closely. First, that he may see whether any part of the theory is inconsistent with the well-established principles of natural philosophy. And secondly, that he may bear the several steps in his memory, as he will find as we proceed that every detail of the mighty catastrophe has been preserved in the legends of mankind, and precisely in the order in which reason tells us that they must have occurred. In the first place, it is, of course, impossible at this time to say precisely how the contact took place. Whether the head of the comet fell into or approached close to the sun, like the comet of 1843, and then swung its mighty tail hundreds of millions of miles in length, moving at a rate of almost to the velocity of and then swung its mighty tail hundred whether the whether the head of the comet whether the head of the comet fell into or approached close to the sun, like the comet of 1843, and then swung its mighty tail hundreds of millions of miles in length, moving at a rate almost equal to the velocity of light, around through a great arc and swept past the Earth. The Earth, as it were, going through the midst of the tail. The Earth, as it were, going through the midst of the tail, which would extend for a vast distance beyond and around it. In this movement, the side of the Earth facing the advance of the tail would receive and intercept the mass of material, stones, gravel, and the finely ground up dust, which, compared by water, is now clay, which came in contact with it while the comet would sail off into space, demoralized, perhaps, in its orbit, like Lexell's comet when it became entangled with Jupiter's moons, but shorn of a comparatively small portion of its substance. The following engraving will illustrate my meaning. I cannot give even approximately the proportions of the objects represented, and thus show the immensity of the sun as compared with our insignificant little orb. There's the engraving here, which too bad the picture's not a little better, but the sun with I can't read what that little line is across the horizontal part. Then there's the little earth and the arc ascribed by the tail, maybe right here. Yeah, interesting. So it looks like it's going to swoosh past the earth there. Wonder how much of this is accepted science still. In a picture showing the true proportions of the sun and earth, the sun would have to be in a picture showing the true proportions of the sun and earth, the sun would have to be so large that it would take up the entire page, while the earth would be as but a pin drop, a pinhead. Excuse me. I made a guess there, and I was wrong. The sun would have to be so large that it would... I have to do that one again. I'm pretty particular in getting it exact. In the meantime, there's the picture, the side of the Earth struck by the comet, Africa, South America, and the side not struck by the comet, Australia, Asia, North America over there. So I don't know. They're just choosing two sides of the Earth there, I guess. And little orb. In a picture showing the true proportions of the sun and Earth, the sun would have to be so large that it would take up the entire page, while the Earth would be but as a pinhead. And I have not drawn the comet on a large... Geez, I almost said pin drop again. I don't know why. Pinhead, pin drop. And I have not drawn the comet on a scale large enough as compared with the Earth. If the reader will examine the map on page 93, he will see that the distribution of the drift accords with this theory. If we suppose the side of the Earth shown in the left-hand figure was presented to the comet, we will see why the drift is supposed to be confined to Europe, Africa, and parts of America, while the right-hand figure will show the half of the world that escaped. The breadth of the tail of the Great Comet of 1811 at its widest part was nearly 14 million miles, the length 116 million miles, and that of the second comet of the same year 140 million miles. On page 95 is a representation of this monster. Imagine such a creature as that with a head 50 times as large as the moon and a tail 116 million miles long, rushing past this poor little Earth of ours, with its diameter of only 7,925 miles. The Earth, 7,925 miles wide, would simply make a bullet hole through that tail, 14 million miles broad where it passed through it. A mere eyelet hole, a pinhole, closed up at once by the constant movements which take place in the tail of the comet. And yet, in that moment of contact, the side of the Earth facing the comet might be covered with hundreds of feet of debris. Or, on the other hand, the comet may, as described in some of the legends, have struck the Earth head-on amidships, and the shock may have changed the angle of inclination of the Earth's axis, and thus have modified permanently the climate of our globe. And to this cause we might look also for the great cracks and breaks in the Earth's surface, which constitute the fjords of the seacoast and the trap extrusions of the continents. And here, too, might be the cause of those mighty excavations, hundreds of feet deep, in which are now the Great Lakes of America, and from which, as we have seen, great cracks radiate out in all directions, like the fractures in a pane of glass where a stone has struck it. Here's the Great Comet of 1811. Check. The cavities in which rest the Great Lakes have been attributed to the ice sheet, but it is difficult to comprehend how an ice sheet could dig out and root out a hole, as in the case of Lake Superior 900 feet deep. And if it did this, why were not similar holes excavated where... And if it did this, why were not similar holes excavated wherever there were ice sheets, to wit, all over the northern and southern portions of the globe? Why should a general cause produce only local results? Sir Charles... Sir Charles Lyell shows that glaciers do not cut out holes like the depressions in which the Great Lakes lie. He also shows that these lakes are not due to a sinking down of the crust of the Earth, because the strata are continuous and unbroken beneath them. Because the He also shows that these lakes are not due to a sinking down of the crust of the earth, because the strata are continuous and unbroken beneath them. He also calls attention to the fact that there is a continuous belt of such lakes, reaching from the northwestern part of the United States through the Hudson's Bay Territory, Canada, and Maine to Finland, and that this belt does not reach below 50-degree north latitude in Europe and 40-degree in America. Do these lie in the track of the Great Collision? The comet, as the stria indicate, come from the north? The, com- the comet, as the stria indicate, came from the north. The mass of Donati's comet was estimated by M. Fay and Roche at about the 700th part of the bulk of the Earth. Monsieur Fay says, excuse me, that is the weight of a sea of 40,000 square miles, 109 yards deep, and it must be owned like that. Check. And it must be owned that. And it must be owned that a like mass animated with considerable velocity might well produce by its shock. Oh, can't even speak. And it must be owned that a like mass animated with considerable velocity might well produce by its shock with the earth very perceptible results. We have but to suppose, and not a reasonable. We have We have but to suppose, a not unreasonable supposition, that the comet which struck the Earth was much larger than Donati's comet, and we have the means of accounting for results as prodigious as those referred to. We have seen that it is difficult to suppose that ice produced the drift deposits, because they are not found where ice certainly was, and they are found where ice certainly was not. But if the reader will turn to the illustration which constitutes the frontispiece of this volume and the foregoing engraving on page 93, he will see that the drift is deposited on the earth as it might have been if it had suddenly fallen from the heavens. That is, it is on one side of the globe, to wit, the side that faced the comet as it came on. I think this map is substantially accurate. There is, however, an absence of authorities as to the details of the drift distribution. But if my theory is correct, the drift probably fell at once. If it had been 24 hours in falling, the diurnal revolution would in turn have presented all sides of the earth to it, and the drift would be found everywhere. And this in accordance with what we know of the rapid movements of comets. They travel, as I have shown, at the rate of 366 miles per second. This is equal to 21,600 miles per minute and 1,296,000 miles per hour. And this accords with what we know of the deposit. And this accords with what we know of the deposition of the drift. It came with terrific force. It smashed the rocks. It tore them up. It rolled them over one on another. It drove its material into the underlying rocks. It indented it into them, says one authority already quoted. It was accompanied by inconceivable winds, the hurricanes and cyclones spoken of in many of the legends. Hence, we find the loose material of the original surface gathered up and carried into the drift material proper. Hence, the drift is whirled about in the wildest confusion. Hence, it fell on the earth like a great snowstorm driven by the wind. It drifted into all hollows. It was not so thick on, or it was entirely absent from, the tops of hills. It formed tails precisely as snow does. On the leeward side of all obstructions, glacier ice is slow and plastic and folds around such impediments and wears them away. The wind does not. Compare the following representation of a well-known feature of the drift. called Crag and Tail, taken from Geeky's work, with the drifts formed by snow on the leeward side of fences or houses. The material runs in streaks, just as if blown by violent winds. Here we have a picture of the Crag and Tail. H. What is H? There's no thing about H. C is the crag and T is the till. I don't know what H is. What does it say H is? Doesn't say what H is. By violent winds. Check. When cut through by rivers or denuded by the action of the sea, ridges of boulders are often seen to be enclosed within it. Although destitute of stratification, horizontal lines are found indicating differences in texture and color. Geeky, describing the boulder clay, says, "It seems to have come from regions whence it is hard to see how they could have been borne by glaciers. As a rule, it is quite unstratified, but traces of bedding are not uncommon. Sometimes it contains worn fossils and fragments of shells, broken, crushed, and striated. Sometimes it contains bands of stones arranged in lines. In short, it appears as if it were gusts and great whirls of the same material as the till, lifted up by the cyclones and mingled with blocks, rocks, bones, sands, fossils, earth, peat, and other matters, picked up with terrible force from the face of the earth and poured down pell-mell on top of the first deposit of true till. In England, 94% of these stones found in this boulder clay are stranger stones. That is to say, they do not belong to the drainage area in which they are found, but must have been carried there from great distances. But how about the markings, the stria, on the face of the surface rocks below the drift? The answer is plain. Debris moving at the rate of 1,000,000 miles an hour would produce just such markings. Check. Dana says, the sands carried by the winds when passing over rocks sometimes wear them smooth or cover them with scratches and furrows, as observed by W.P. Blake on granite rocks at the pass of San Bernardino, California. Even quartz was polished and garnets were left projecting upon pedestals of feldspar. Limestone was so much worn as to look as if the surface had been removed by solution. Similar effects have been observed by Winchell in the Grand Traverse region, Michigan. Glass in the windows of houses on Cape Cod sometimes has holes worn through it by the same means. The hint from nature has been The hint from nature has led to the use of sand driven by a blast with or without steam for cutting and engraving glass, and even for cutting and carving granite and other hard rocks. Gratacap describes the rock underneath the till as polished and oftentimes lustrous. But it may be said, if it be true that debris driven by a terrible force could have scratched and dented the rocks, could it have made long, continuous lines and grooves upon them? But the fact is, the stria on the face of the rocks covered by the drift are not continuous. They do not indicate a steady and constant pressure, such as would result where a mountainous mass of ice had caught a rock and held it, as it were, in its mighty hand, and thus holding it steadily had scored the rocks with it as it moved forward. The groove is of irregular depth, its floor rising and falling as though hitches had occurred when it was first planed, the great chisel meeting resistance or being thrown up at points along its path. What other results would follow at once from contact with the comet? We have seen that to produce the phenomena of glacial age, it was absolutely necessary that it must have been preceded by a period of heat, great enough to vaporize all the streams and lakes and a large part of the ocean. And we have seen that no mere ice hypothesis gives us any clue to the cause of this. Would the comet furnish us with such heat? Let me call another witness to the stand. In the great work of Amédée Guillaume, already cited, we read, "On the other hand, it seems proved that the light of the comets is, in part at least, borrowed from the sun. But may they not also possess a light of their own? And on this last hypothesis, is this brightness owing to a kind of phosphorescence or to the state of incandescence of the nucleus? Truly, if the nuclei of comets be incandescent, the smallness of their mass would eliminate from the danger of their contact with Earth only one element of destruction. The temperature of the terrestrial atmosphere would be raised to an elevation inimical to the existence of organized beings, and we should only escape the danger of a mechanical shock to run into a not less frightful one of being calcined in a many days passage through an immense to run into a not less and we should only check. Just going to redo that last part. Check. And we should only escape the danger of a mechanical shock to run into a not less frightful one of being calcined in a many days passage through an immense furnace. Here we have a good deal more heat than is necessary to account for that vaporization of the seas of the globe which seems to have taken place during the drift age. But similar effects might be produced in another way, even though the heat of the comet itself was inconsiderable. Suppose the comet, or a large part of it, to have fallen into the sun. The arrested motion would be converted into heat. The material would feed the combustion of the sun. Some have theorized that the sun is maintained by the fall of cometic matter into it. What would be the result? Mr. Proctor notes that in 1866, a star in the constellation Northern Cross suddenly shone with 800 times its former luster, afterward rapidly diminishing in luster. In 1876, a new star in the constellation Cygnus became visible, subsequently fading again so as to be only perceptible by means of a telescope. The luster of the star must have increased from 500 to many thousand times. Mr. Proctor claims that should our sun similarly increase in luster even 100-fold, the glowing heat would destroy all vegetable and animal life on Earth. There is no difficulty in seeing our way to heat enough, if we concede that a comet really struck the Earth or fell into the sun. The trouble is, in the other direction, we would have too much heat. We shall see hereafter that there is evidence in our rocks that in two different ages of the world, millions of years before the drift period, the whole surface of the Earth was actually fused and melted, probably by cometic imp. Another mistake at the end of the long sentence, which I'll have to redo the whole thing. It's all right. We shall see hereafter that there is evidence in our rocks that in two different ages of the world, millions of years before the drift period, the whole surface of the Earth was actually fused and melted, probably by cometic contact. This Earth of ours is really a great powder magazine. There is enough inflammable and explosive material about it to blow it into shreds at any moment. Sir Charles Lyell quotes approvingly the thought of Pliny. It is an amazement that our world so full of combustible elements stands a moment unexploded. It needs but an infinitesimal increase in the quantity of oxygen in the air to produce a combustion which would melt all things. In pure oxygen, steel burns like a candle wick. Nay, it is not necessary to increase the amount of oxygen in the air to produce terrible results. It has been shown that of our 45 miles of atmosphere, 1/5, or a stratum of 9 miles in thickness, is oxygen. A shock or an electrical or other convulsion, which would even partially disarrange or decompose this combination and send an increased quantity of oxygen, the heavier gas, to the earth, would wrap everything in flames. Or the same effects might follow from any great change in the constitution of the water of the world. Water is composed of 8 parts of oxygen and 1 part of hydrogen. The intensest heat by far ever yet produced by the blowpipe is by the combustion of these 2 gases. And Dr. Robert Hare of Philadelphia found that the combination which produced the intensest heat was that in which the 2 gases were in the price found that, and Dr. Check. And Dr. Robert Hare of Philadelphia found that the combination which produced the intensest heat was that in which the 2 gases were in the precise proportions found in water. We may suppose that this vast heat, whether it came from the comet or the increased action of the sun, preceded the fall of the debris of the comet by a few minutes or a few hours. We have seen the surface rocks described as lustrous. The heat may not have been great enough to melt them, it may merely have softened them, but when the mixture of clay, gravel, striated rocks, and earth sweepings fell and rested on them, they were at once hardened and almost baked. And thus we can account for the fact that the till, which lies next to the rocks, is so hard and tough compared with the rest of the drift that it is impossible to blast it and exceedingly difficult even to pick it to pieces. It is more feared by workmen and contractors than any of the true rocks. Check. Professor Hart shows that there is evidence that some cause, prior to but closely connected with the drift, did decompose the surface rocks underneath the drift to great depths, changing their chemical composition and appearance. Professor Hart says, in Brazil and in the United States, in the vicinity of New York City, the surface rocks under the drift are decomposed from a depth of a few inches to that of 100 feet. The feldspar has been converted into slate, and the mica has parted with its iron. Professor Hart tries to account for this metamorphosis by supposing it to have been produced by warm rains. But why should there be warm rains at this particular period? And why, if warm rains occurred in all ages, were not all the earlier rocks similarly changed while they were at the surface? Hauser. Check. Hauser and Clairez suppose this decomposition of the rocks to be due to nitric acid. Hauser and Clairez suppose this decomposition of the rocks to be due to nitric acid. But where did nitric acid come from? In short, here is the proof of the presence on the earth just before the drift struck it, of that conflagration which we shall find described in so many legends. And certainly the presence of ice could not decompose rocks 100 feet deep and change their chemical constitution. Nothing but heat could do it. But we have seen that the comet is self-luminous, that is, it is in process of combustion. It emits great gushes and spouts of luminous gases. Its nucleus is enveloped in a cloak of gases. What effect would these gases have upon our atmosphere? First, they would be destructive to animal life, but it does not follow that they would cover the whole earth. If they did, all life must have ceased. They may have fallen in places here and there in great sheets or patches and have caused, until they burn themselves out, the conflagrations with Check. They may have fallen in places here and there in great sheets or patches and have caused, until they burn themselves out, the conflagrations which the traditions tell us accompanied the great disaster. Secondly, by adding increased proportions to some of the elements of our atmosphere, they may have helped to produce the marked difference between the preglacial and our present climate. What did these gases consist of? Here, that great discovery, the spectroscope, comes to our aid. But if we are able to tell the elements that are being consumed in remote stars, by it we have learned that comets are in part self luminous and in part shine by the reflected light of the sun. By it, we are even able to identify the very gases that are in a state of combustion in comets. In Schellen's great work, I find a cut, see next page, comparing the spectra of carbon with the light emitted by two comets observed in 1868, Winnicke's comet and Brorson's comet. Here we see that the self luminous parts of these comets burned with substantially the same spectrum as that emitted by burning carbon. The inference is irresistible that these comets were wrapped in great masses of carbon in a state of combustion. This is the conclusion reached by Dr. Schellen. Padre Secchi, the great Roman astronomer, examined Dr. Winnicke's comet on the 21st of June, 1868, and concluded that the light from the self luminous part was produced by carbureted hydrogen. And here is the picture: solar spectrum, spectrum of carbon in olive oil, spectrum of carbon in olefiant gas, Winnicke's comet the second, 1868, Brorson's comet the first, 1868. Huh. Check. We shall see that the legends of the different races speak of the poison that accompanied the comet and by which great multitudes were slain. The very waters that first flowed through the drift, we are told, were poisonous. We have but to remember the carbureted hydrogen is the deadly fire damp of the miners to realize what effect great gusts of it must have had on animal life. We are told that it burns with a yellow flame when subjected to great heat. Lost my place there. We are told that it burns with a yellow flame when subjected to great heat, and some of the legends we will see hereafter speak of the yellow hair of the comet that struck the Earth. And we are further told that when it carbureted oxygen, it mixed in due proportion with oxygen or the atmospheric air, a compound is produced which explodes with the electric spark of the. It mixed in. I'm just going to redo that whole sentence here. And we are. Spark of the electric spark of the. I've lost. I think I messed up here. In due proportion with oxygen or the atmospheric air, a compound is produced which explodes with the electric spark of the. I've lost myself here. This could be a problem. This is why it's a risk doing it live. I've messed myself up here. After speak of the yellow hair of the comet that struck the Earth. The yellow hair of the comet that struck the Earth. Where was that again? I thought that was pretty close by. The yellow hair, was it after this? The yellow hair that's huh. Well, that's not too bad, I guess. We will see hereafter speak of the yellow comet that's. Okay, so I'm just going to try one more thing before I continue, redo all this. Redo record. That didn't do anything. Hair of the comet that struck the Earth. Undo record. Okay, I better just do this. Carbureted. And oh boy, what's going on? Okay, check. And why is that red now? Is that always red? And we are further told that when it carburetted oxygen is mixed in due proportion with oxygen or atmospheric air, a compound is produced which explodes with the electric spark or the approach of flame. Another form of carburetted oxygen, olefiant gas, is deadly to life, burns with a white light, and when mixed with 3 or 4 volumes of oxygen or 10 or 12 of air, it explodes with terrific violence. We shall see hereafter that many of the legends tell us that as the comet approached the Earth, that is, as it entered our atmosphere and combined with it, it gave forth world appalling noises, thunders beyond all earthly thunders, roarings, howlings, and hissings that shook the globe. If a comet did come, surrounded by volumes of carburetted oxygen, if a comet did come, surrounded by volumes of carburetted hydrogen, if a comet did come, surrounded by volumes of carburetted hydrogen or carbon combined with hydrogen, the moment it reached far enough into our atmosphere to supply it with the requisite amount of oxygen or atmospheric air, precisely such dreadful explosions would occur, accompanying by noise. Let me redo that whole thing here. Let's see. This is shook the globe. How the sausage is made. Except I would be using large screens for this, but if a comet did come, surrounded by volumes of carburetted hydrogen or carbon combined with hydrogen, the moment it reached far enough into our atmosphere to supply it with the requisite amount of oxygen or atmospheric air, precisely such dreadful explosions would occur, accompanied by noises similar to those described in the legends. Let us go a step further. Let us try to conceive the effects of the fall of the material of the comet upon the Earth. We have seen terrible rainstorms, hailstorms, snowstorms, but fancy a storm of stones and gravel and clay dust, not a mere shower either, but falling in black masses, darkening the heavens, vast enough to cover the world in many places, hundreds of feet in thickness. Oh, I can hear my cat in the background coming. He's gonna start bugging me. Here he comes. Leveling valleys, tearing away and grinding down hills, changing the whole aspect of the habitable globe. Without and above it roars the earthquaking voice of the terrible explosions. Through the drifts of debris, glimpses are caught of the glaring and burning monster, while through it all, over and over, is an earthly. check. While through all and over all is an unearthly heat, under which rivers, ponds, lakes, springs disappear as if by magic. Now, reader, try to grasp the meaning of all this description. Do you merely read? do you do you do not merely read the words? To read aright upon any subject, you must read below the words, above the words, and take in all the relations that surround the words. So read this record. Look out at the scene around you. Here are trees 50 feet high. Imagine an instantaneous descent of granite, sand, and gravel sufficient to smash and crush these trees to the ground, to bury their trunks, and to cover the earth 100 to 500 feet higher than the elevation to which their tops now reach. And this not alone here in your garden or over your farm or over your township or over your country or over your state, but over the whole continent in which you dwell. In short, over the greater part of the habitable world. Are there any words that can draw even faintly such a picture? Its terror, its immensity, its horrors, its destructiveness, its surpassal of all earthly experience and imagination. And this human anthill, this world, how insignificant would it be in the grasp of such a catastrophe? Its laws, its temples, its libraries, its religions, its armies, its mighty nations would be but as the veriest stubble, dried grass, leaves, rubbish, crushed, smashed, buried under this heaven rain of horrors. But lo, through the darkness, the wretches not beaten down and whelmed in the debris, but scurrying to mountain caves for refuge, have a new terror. The cry passes from lip to lip. The world is on fire. The head of the comet sheds down fire. Its gases have fallen in great volumes on the earth. They ignite amid the whirling and rushing of the debris caught in cyclones, rise as the glare of a titanic conflagration. The winds beat the rocks against the rocks. They pick up sand heaps, peat beds, and boulders and whirl them madly in the air. The heat increases. The rivers, the lakes, the ocean itself evaporate. And poor humanity, burned, bruised, wild, crazed, stumbling, blown about like feathers in the hurricanes, smitten by mighty rocks. They perish by the million. A few only reach the shelter of the caverns, and thence, glaring backward, look out over the ruins of a destroyed world. And not humanity alone has fled to these hiding places. The terrified denizens of the forest, the domestic animals of the fields, with the instinct which in great tempests has driven them into the houses of men, follow the refugees into the caverns. We shall see all this depicted in the legends. The first effect of the great heat is the vaporization of the waters of the earth. But this is arrested long before it has completed its work. Still, the heat is intense. How long it lasts, who shall tell? An Arabian legend indicates years. The stones having ceased to fall, the few who have escaped, and they are few indeed, for many are shut up forever in the clay dust. they are And they are few indeed, for many are shut up forever by the clay dust and gravel in their hiding places, and on many others the convulsions of the earth have shaken down the rocky roofs of the caves. The few survivors come out or dig their way out to look upon a changed and blasted world. No cloud is in the sky, no rivers or lakes are on the earth. Only the deep springs of the caverns are left. The sun, a ball of fire, glares in the bronze heavens. It is to this period that the Norse legend of Mimir's Well, where Odin gave an eye for a drink of water, refers. I am just going to double check that pronunciation. My voice is going in my throat. Memers. Perfect. Check. Okay, got about 4 pages left here, almost done. But gradually the heat begins to dissipate. This is a signal for tremendous electrical action. Condensation commences. Never has the air held such incalculable masses of moisture. Never has heaven's artillery so rattled and roared since Earth began. Condensation means clouds. We will find hereafter a whole body of legends about the stealing of the clouds and their restoration. The veil thickens, the sun's rays are shut out. It grows colder. More condensation follows. The heavens darken. Louder and louder bellows the thunder. We shall see the lightnings represented in myth after myth as the arrows of the rescuing demigod who saves the world. The heat has carried up perhaps 1/4 of all the water of the world into the air. Now it is condensed into cloud. We now have an ordinary storm. Check. We know how an ordinary storm darkens the heavens. In this case, it is black night. A pall of dense cloud many miles in thickness enfolds the earth. No sun, no moon, no stars can be seen. Darkness is on the face of the deep. Day has ceased to be. Men stumble against each other. All this we shall find depicted in the legends. The overloaded atmosphere begins to discharge itself. The great work of restoring the waters of the ocean to the ocean begins. It grows colder, colder, colder. The pouring rain turns into snow and settles on all the uplands and north countries. Snow falls on snow. Gigantic snowbeds are formed, which gradually solidify into ice. While no mile-thick ice sheets descends to the Mediterranean or the Gulf of Mexico, glaciers intrude into all the valleys, and the flora and fauna of the temperate regions become Arctic. That is to say, only these varieties of plants and animals survive in those regions that are able to stand the cold, and these we now call Arctic. In the midst of this darkness, check. In the midst of this darkness and cold and snow, the remnants of poor humanity wander over the face of the desolated world, stumbling, awestruck, but filled with an insatiable hunger which drives them on, living upon the bark of the few trees that have escaped, or on the bodies of the animals that have perished, and even upon one another. All this we shall find plainly depicted in the legends of mankind as we proceed. Steadily, 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 for days, weeks, months, years, the rains and snows fall, and as the clouds are drained, they become thinner and thinner, and the light increases. It has now grown so light that the wanderers can mark the difference between night and day, and the evening and the morning were the first day. Day by day, it grows lighter and warmer. The piled up snows begin to melt. It is an age of tremendous floods. All the low-lying parts of the continents are covered with water. Brooks become mighty rivers, and rivers are floods. The drift debris is cut into by the waters, rearranged, piled up in what is called the stratified secondary or Champlain drift. I'm just going to redo that guy quickly. The drift. The drift debris is cut into by the waters, rearranged, piled up in what is called the stratified secondary or Champlain drift. Enormous river valleys are cut out of the gravel and clay. The seeds and roots of trees and grasses, uncovered by the rushing torrents and catching the increasing warmth, begin to put forth green leaves. The sad and party-colored earth, covered with white, red, or blue clays and gravels, once more wears a fringe of green. The light increases, the warmth lifts up. The light increases. The light increases. The warmth lifts up. The warmth lifts. The light increases. The warmth lifts. The light increases. The warmth lifts up part of the water already cast down, and the outflow of the streaming ice fields. The warmth. The light increases. The warmth lifts up part of the water already cast down, and the outflow of the steaming ice fields, and pours it down again in prodigious floods. It is an age of storms. The people who have escaped gather together. They know the sun is coming back. They know this desolation is to pass away. They build great fires and make human sacrifices to bring back the sun. They point and guess where he will appear. And for they have lost all knowledge of the cardinal points. And all this is told in the legends. At last, the godlike, the resplendent luminary breaks through the clouds and looks again upon the wrecked earth. Oh, what joy! Beyond all words comes upon those who see him. They fall upon their faces. They worship him who dread. They fall upon their faces. They worship. Check. They fall upon their faces. They worship him whom the dread events have taught to recognize as the great God of life and light. They burn or cast down their animal gods of the pre-glacial time, and then begins that worldwide worship of the sun, which has continued down to our times. And all this, too, we shall find told in the legends. And from that day to this, we live under the influence of the effects produced by the comet. The mild, eternal summer of the tertiary age is gone. The battle between the sun and the ice sheets continues. Every north wind brings us the breath of the snow. Every south wind is part of the sun's contribution to undo the comet's work. A continual amelioration of climate has been going on since the glacial age. And if no new catastrophe falls on the earth, our remote posterity will yet see the last snowbank of Greenland melted and the climate of the Eocene reestablished in Spitsbergen. Last page, and then it's chapter 3 of the legends, which maybe I'll do tomorrow. It has been suggested that the warmth of the tertiary climate was simply the effect of the residual heat of the globe cooling from incandescence, but many facts disprove this. For example, the fossil plants found in our lower Cretaceous rocks in central North America indicate a temperature climate in latitude 35 degree to 40 degree in the Cretaceous age. The coal flora, too, and the beds of coal indicate a moist, equable, and warm but not hot climate in the Carboniferous age, millions of years before the Tertiary, and 3,000 miles farther than and 3,000 miles far, and 3,000 miles farther south than localities where magnolias, tulip trees, and deciduous cypresses grew in the latter age. Some learned and check, check. Some learned and cautious geologists even assert that there have been several ice periods, one as far back as the Devonian. The ice fields and wild climate of the poles and the cold which descends annually over Europe and North America represent the residuum of the refrigeration caused by the evaporation due to the comet's heat and the long absence of the sun during the age of darkness. Every visitation of a comet would therefore necessarily eventuate in a glacial age, which in time would entirely pass away, and our storms are bred of the conflict between the heat and cold of the different latitudes. Hence, it may be that the tertiary climate represented the true climate of the Earth, undisturbed by comet catastrophes, a climate equable, mild, warm, stormless. Think what a world this would be without tempests, cyclones, ice, snow, or cold. Let us now turn to the evidences that man dwelt on the earth during the drift, and that he has preserved recollections of the comet to this day in his myths and legends. Interesting how it kind of started to click with me about the legends of the solar myths and the solar deities and stuff, and how man, they would have really like started paying attention to the seasons and where the sun was and tracking it all. Like maybe that's why they're tracking these celestial markers so much from thousands of years ago. Anyway, thank you very much for watching the video. I'm sure this will be out on audio, fully edited and stuff at some point. Um, hopefully, I'm going to talk to Randall about it. Hopefully, he'll listen to it. I'd love to know how much of this science has changed since then. Anyways, thanks for watching, listening, like and subscribe, all that good stuff, and I'll see you again.